Welcome in our mathematics class. Today we are going to look at the number patterns, just as we had seen at it in our previous class. Now, just before we move on, I want us to look and review what these number patterns were and what exactly was our duty of approaching the number patterns. Now, first, I want us to understand the two issues. This is what we call the sequence and what we call term. Now, number patterns are also known as sequences. And this sequence are formed by certain numbers. Each of these numbers is what we refer to as a term. Now, for the particular number pattern, we need to be able to know how this sequence will flow. So there are strategies that are normally used to determine or that are normally involved in the number sequence so that one is able to know what will be the next term given a sequence of numbers. So here, as we follow these strategies, we do it by looking through various ways of approaching at the relationship of the sequence. We can do this by looking at what we call the common difference. We can do this by looking at the common difference. When you talk about a common difference, I want you to look at it this way. When you have a number, two numbers, two terms, when you subtract one of the terms or numbers from the other one, what you have is a difference. But when two or three or four numbers, the difference is constant, then we say that there is what we call a common difference. So a common difference is developed from a sequence of numbers of which the next term, subtract the previous term, is giving us a number that remains constant across the difference of all the other terms. That means that there is a common difference, and that's why we are saying that we can identify or we can be able to come up with the next term or to identify a sequence of numbers by looking at the common difference. Here we shall expect either the terms increasing constantly or the terms decreasing constantly with a constant common difference. For example, we have 6, 10, 14, 18, and so on. We can have 22, 19, 16, 13, and so on. What do you actually discover when you look at the difference between these numbers? And how is the next number being generated? I want us to put our concentration between the numbers. So you will realize that in the first one, there is a difference of 4. So from 6 to 10, there is 4. Between 10 and 14, there is 4. And between 14 and 18, there is 4. So we can conclude and say that there is a common difference of 4. And if that is the case, if we are asked to identify the next term, we shall know that from 18 we are supposed to add 4. That gives us the next term as 22. For this other one, if you are very keen, you realize that to get the next term, we are subtracting 3. We are subtracting 3. 22 minus 19 is 3. 19 minus 16 is 3. 16 minus 13 is 3. So there is a constant subtraction of 3 to arrive in the next term. If we needed to have the next term here, we would have it as 10, simply because 13 minus 3 is equals to 10. This is what we call a common difference. This is how we can arrive at the next term or study a sequence of numbers by looking at what we call the common difference. We may also strategize to come up with knowing the behavior of a sequence of numbers using what we call common ratio. Looking for a common ratio. When we talk about a ratio in mathematics, mostly we would say it's a certain number to the other or over the other, raised to another, or divided to another. If that division that we are getting, if the quotient we are getting is constant across the terms, then we shall say that there is a common ratio between a pattern of numbers. Now, I want us to look at how we come up with a ratio and see whether it will form a sequence of numbers or not. Let us take, for example, 2, 4, 8, and then 16, and then 32, and so on. We have this. What would be the next term? And before we go to the next term, we want to study the relationship in between the terms. How was the next term being arrived at? You realize that to arrive at 4, you should have noticed that the first term has been multiplied by 2. Which implies that to get the other one, we shall multiply the previous term by 2, and we get a number like 64. In this particular case, we have a common ratio. Every point we find that each term is being multiplied by 2 to get the next term. Sometimes we may say that we divide the next term by 2 to get the previous. So we are saying that here the common ratio is 2. The common ratio is 2. We can also study a sequence of numbers or number patterns, and by doing so, we do it by looking for an increasing by looking for an increasing or decreasing difference. Looking for an increasing or decreasing difference. Now, in a case where we have a sequence of numbers or we have a number pattern, and when you look at these patterns, there is a possibility of a difference, but this difference is either increasing or it is decreasing. It is a difference, not like the other part, but there is some difference which keeps on constantly increasing by a certain value. Take, for example, the number pattern 1, 3, 6, 10, and 15. The number pattern we have here, it is the duty of you as a learner to look at the number pattern, to think, to analyze, to look at what could be the possible behavior of in between the terms that keeps on recurring. Right? So if that is the case here, let us consider the first two terms, the next two terms, pair of terms, as we realize, as we look at it. Now, we are talking of either increasing or decreasing difference. Now, when you look at this, the difference between 3 and 1 is 2. The difference between 3 and 6 is 3. The difference between 6 and 10 is 4. And the difference between 15 and 10 is 5. Definitely, the difference between the next term and the previous here is expected to be 6. And now you realize that the difference that is being formed here, in this case, is increasing. We are looking for an increasing difference. The first difference was 3, and then 2, and then... So you can move on and on and on. Every time the difference increases by 1. So we can find that the next term for this particular sequence, it is 15 plus 6, which gives us 21. So we find that we can have a sequence of numbers which is related to others by the increasing difference. Sometimes it's not a must that it can be increasing. It can also be decreasing. It can also be decreasing. Look at, like for this particular case, if someone... Can you look at this pattern and see what is happening or how are you approaching it? we have 1, 2, 3, 4. We have a sequence of numbers here. I want you to look at it keenly and see what is the relationship or what are you able to identify. We are talking about either increasing or decreasing difference. Now, here the difference between 30 and 42 is 12. The difference between 20 and 30 is 10. The difference between 12 and 20 is 8. The difference between 6 and 12 is 6. The difference between 2 and 6 is 4. Now, there is a pattern here. There is some flow of a difference, and the difference keeps on decreasing. And as it decreases, you'll notice that it is decreasing, yes, but by a minus 2. So we can say that this number pattern that we have is a sequence of numbers that is decreasing. And it is decreasing in a way that the difference keeps on also decreasing. So that's why we have this. So if we were to look for the number, this next number, it would be a 2. So 2 minus 2 gives us a 0. It keeps on decreasing. So this is either when we have it increasing or when we have it decreasing. Now, sometimes we have to identify a sequence by looking for an interlinked patterns. Now, when we talk about interlinked patterns, there is a possibility of some patterns whereby these patterns are either increasing as they interchange or decreasing as they interchange. It could be a pattern of odd numbers. It could be a pattern of even numbers. If we have such pattern, then we say that the two patterns are interlinked. And in this particular case, we shall look at the behavior of maybe the odd numbers and the behavior of the even numbers. We can have a number like 2, now, we have a certain sequence here. First, what you notice, we are having even, odd, even, odd, even, odd. When you try to look at it and maybe identify the difference, you find that you are not able to tell the difference simply because maybe there is you may think it is adding 1, but reaching here, then the pattern again breaks up. You come here, 6 and 5, they have interchanged, maybe it is decreasing. You move here, the pattern again changes up. Then you say, what could be the problem? I want you to look at it this way. Consider the odd numbers independently, and then also consider the even numbers also independently. If you happen to look at the odd numbers and look at the even numbers, in this particular case, there is a pattern that you are going to find. You'll realize that when you look at the even numbers there, and then look at the odd numbers down here, there is something happening. There is something happening, and that one can also easily link us even to the next term. So, there is, for even numbers, there is a tendency of a plus 4. For odd numbers, there is a tendency of a plus 2. So if you were to look at the next term that is supposed to come here, which is supposed to be even, it is plus 4, which gives us 14. And for the other one, it is plus 2, which gives us 9. So it doesn't matter how a number pattern looks like. The very important thing is you look for a way out and develop the relationship. Find what links. That's why we are calling it interlinked pattern. And here we are. This pattern here is interlinked by the odd numbers, and it is also linked by the even numbers. That is why we have it like that, looking for an interlinked pattern. The next way we can work on number patterns is looking for a special type of pattern. We sometimes have a pattern. This pattern requires you to find out ways out, to find the best way out and see how has the terms behaved. How is the next term being generated? Number patterns is a mathematical concept that requires you, the learner, to reason out wider. So when we have special type of pattern, it is not that it is just specific. It is the duty of you as a learner to look at what could be the possible special pattern in a sequence of numbers. Now, this special type of pattern varies. It could be a square of a number. It would be cubes. It would be square roots, and so on. We are looking at special pattern. And then, if you happen to identify the special pattern that exists on that particular number pattern, you are there to get to the next term and easily move on. Look at this number and see how it behaves. We have a sequence of numbers. And in a sequence of a number here, we have 1, 8, 27, 64, and so on. You try to look for a common difference. No, it's not coming up. You try to look at common ratio. It's not adding up. You try to look at maybe interlinked behavior or patterns again. Nope, it's not working. What could happen here? This is now what calls for what we call the special type of pattern. Now for this, if you study it very, very closely, you'll see that each of the terms given or the numbers given are numbers which you can easily get the cube root. The cube root. The cube root of a number means that if a number is multiplied by itself 3 times, it forms a root of 3. Therefore, you'll realize that this is equivalent. So I'm going to take the cube root of every term at any given time, and you'll find that cube root of 1 is 1. Therefore, 1 cubed still gives us a 1. Cube root of 8 is 2. Therefore, 2 cubed is the same as 8. So you realize this is the relationship. This is the relationship. This is simply a pattern of cubes of numbers. This particular pattern, it is a pattern of cubes of numbers. So the number is increasing, 1, 2, 3, and so on, but with a cube. 1 cubed, 2 cubed, 3 cubed, and so on. So this is simply an example of maybe a special type of pattern. And not just that, we can also develop our own number using the squares. There's nothing wrong. And now we want to develop the one for the squares, but this time now we bring about two relationships in it. Look, for example, at this. I want you to look at this. This is a pattern of numbers. This is a sequence of numbers. Now, but what is happening here? What is the relationship here? You'll find that every number you are finding, it's a perfect square. If a number is perfect square, meaning its square root is even. We don't remain with the remainder. So the square root of 1 is 1, square root of 9 is 3, square root of 25 is 5, then this one is 7, this one is 9. Take note of this. The pattern formed here, you'll find that they are odd numbers, and the odd numbers are squared. So you can simply say this is a pattern formed by the squares of odd numbers. The squares of odd numbers. So we have created a sequence here on this other number of odd numbers, and then we have squared the numbers to have our pattern. So sometimes it's not a matter that it can only be 1, 2, 3, 4 increasingly. It can also require us to identify another pattern that exists here, and you'll find that at any given time there is a common difference. They are adding 2. Or we simply say it's simply a square of odd numbers. This is the pattern. Now, having said that, and having looked at various possible strategies of identifying and analyzing a sequence, let us look at the questions. question, find the next three terms at least for these numbers which have a common difference. And the first number we have, sequence we have is 6, 18, 30 and 42, so on, and the other one is 99, 92, 85 and 78, and so on. So, because it's about the common difference, let us study the first part and see what is the common difference between 6, 18, 30, and 42. You realize that the difference between the two terms we have is 12. So they are adding 12. So we want to get the next three terms. We want to get the next three terms. Then it means that we must add plus 12 here. We must add plus 12 here, plus 12 here. If you do that, you'll find that we have 42 plus 12 is 54. 54 plus 12, you have 66. And 66 plus 12 is 78. So the next three terms required in this sequence is 54, 66, and 78. Take note that the increase is a common difference of 12. For this other one, let us start by looking at what could be the difference between the terms that we have. We find that 9 and 92, we have a minus 7. So minus 7 here, minus 7 here, which implies that if we have to get the missing terms, these three terms here, we should get by subtracting 7 at every point. We should get it by subtracting 7 at any given point. And if that is the case, then it means that when you take 78 minus 7, you find you'll have here 71. Then take 71 minus 7, you'll get 64. 64 minus 7, you get 57. The common pattern that is existing in between these, there is a common difference of 7. We are developing the next term by subtracting 7. We have this question, find the next three terms for the following number patterns which have a common ratio. 2, 6, 18 and 54, 256, 128, 64, 32, and so on. So let's start with the first one. First, it is necessary for us to know what is the common ratio. To get the common ratio is either take the first one divided by the second one, the next term divided by the previous term. For this case, 6 divided by 2 is 3. 18 divided by 6 is 3. 54 divided by 18 is 3. So you take 2, multiply by 3 is 6. Take 6, multiply by 3 is 18. Take 18, multiply by 3 is 54. Take 54, multiply by 3, you'll find that it is 162. So next time we shall have 162. Take 162, multiply by 3, you get 486. Take 486, multiply by 3, you'll get 1,458. For us to get this, we took the terms that we had, divided them by the previous one. We found that there was a common ratio of 3. Therefore, from the previous term to get the next term, we multiply by 3. We multiply by 3. If you multiply by 3, you'll always get the next term. So from 54, keep multiplying by 3. You get 162, you get 486, and you get 1,458. Now, for this other one, 256, 128. Then we have 64, 32, and so on. What do you realize here? We need to find the relationship between 256, 128, 64, 32. You'll notice that in this particular question, we need to find the ratio between these terms. And you'll find that this 128 is technically simple. It's a half of the previous. A half of 256 is 128. A half of 128 is 64. A half of 64 is 32. So what we are realizing is that we are multiplying here by a half. So if there is that ratio, how do we get the ratio here? The ratio is simple. 128 divided by 256 is a half. So you multiply the previous term by a half, you'll get the next one. So you realize that if we had 256 multiplied by a half, this one by 2, 1 by 2 is 128. This is what I'm saying. So if that is the case, then for 32 to get the next term, we shall multiply it by 1 over 2. 32 multiplied by a half will give us 16, and then by a half again, it will give us 8, and then it will give us 4. So we are multiplying by half at any given interval. So the numbers required is 16, 8, and 4. 16, 8, and 4. Bado ngapi hapo? Bado 20. Ondoka. So this is the approach of the patterns. We can also look at further questions and see the kind of approaches that we can make while approaching the patterns. So let us look at more questions and see how to approach the number patterns and develop it. Find the next three terms of the following number patterns which have a common ratio: 2, 4, 8, 16, and so on. And we have 7, 70, 700, 7,000, and so on. We need to find the next three terms. Anytime we are approaching a question on number patterns, the very first thing is find the strategy that is going to be used. Already we have a hint it is a common ratio. Then we need to find out how is this common ratio being identified. We don't only use one pair of numbers, but we need to use variety of numbers. So for the first one, where we have 2, 4, 8, and 16, it is very, very straight at us. So you can see that the relationship between the two is that the previous term, when multiplied by 2, you get the next term, and so on. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So the common ratio is 2 in that particular case. To get the other numbers is 16 times 2, which is 32, then times 2, which is 64, then times 2, which is 128. So the terms are very, very clear. But sometimes we go, when we are looking at the numbers formed by 10, or the multiples of 10, and when you go to such question, it will bring us to question number 2. In this question, we have to find the next numbers between, we have 770, 700 and 7. This is 7,000. Now, study the relationship. What do you identify? If you take 70 divided by 7, what do you get? You'll get, it's a 10. So 7 times 10, it is 70. 700 divided by 70 is 100. 7,000 divided by 700 is 1. You'll find that 7,000 divided by 700 divided by 70 is 10. 7,000 divided by 700 is 10. So what you get here, everything you are getting, you are multiplying by 10. Which means 7,000 should be multiplied by 10 to get 70,000. 70,000 should be multiplied by 10 to get 700,000. 700 should be multiplied by 10 to get 7 million. So what is our common ratio? The common ratio here is 10. So at any given time, when you multiply the previous number by 10, you'll always find the next number. So sometimes in number pattern, you will not only be asked to find the other numbers, but you can also, in number pattern, sometimes you can also be asked to fill in the missing terms. So that they have given you a series of number, some areas are blank, so it's upon you as a learner to identify which area you're going to use to develop your number pattern. So let us look at this question, of which here now we want to find the missing numbers in the pattern. So we want to look at this. When we are asked to fill in, it's an open question. So it means that you are not going to say this one is maybe focusing on common ratio, this one is focusing on common difference or interlinked pattern. It is a duty for us to simply find a better way of approaching such a question. Supposed to find a better way to approach such question. What are they adding, or what are they subtracting, or what are they multiplying with for us to find the next one? So it is always necessary. You can use your calculator, you can use your mobile phones to calculate if you have the application, but it's very necessary that we first need to identify the best way to approach the issues. Now, we want to find the relationship being formed here. What is the relationship? Now, first, you notice that this is 14 and this is 42. We shall try various ways and find out. The difference between 14 and 42, the difference between 14 and 42, when you can take 42 minus 14, this one gives us 28. So they have added here a 28. Then, can we try to find out that, if we add here 28, is it going to give us this term here as 26? If it will not give us 26, it means that we have come up with the wrong method of the sequence, so we try a different one. So 42 plus 28 we get is 70. So this is 70. 70 plus 28, this is 98. And then now 98, so we are filled here. 98 plus 28, will it give us 126? It is giving us 126. 126 plus 28 giving us 154. Now, you realize that the pattern has simply been identified, and at any given time, the previous term added 28, you get the next one. It would have been very tricky because 42 also and 14 has got a relationship. If you had taken 42 divided by 14, that would be about 3. So that we multiply each number by 3, then we see, let us try that and see whether it would have worked. Because someone would have seen that and decided to multiply. 42 times 3, it would give us, this is giving us 126. So if you already have 126 and you still have 126 on the pattern, that one is a wrong approach. So find the best correct common ratio that exists, the common difference that exists. And in this case, the common difference is increasing by adding 28. For the second one, we find out how the pattern is 65 and 75. The difference is 10. So let us go subtract 10 and see. Will this 35 be maintained, and will this 15 be also maintained? If the difference here is 10, then 65 minus 10, minus 10 should give us 55. 55 minus 10 should give us 45. 45 minus 10 should give us 35. And 35 minus 10 should give us 25. I'm really saying minus as a right plus because I'm coming backwards. So if 15, when we move to the right, we are adding 10 at any given point when we add the numbers. So we can conclude and say that in number patterns, we can either be asked to find the missing numbers, the way we've seen here, or you can be asked to find the next pattern. Sometimes you'll also be asked to study the sequence and interpret and tell if that sequence requires the common ratio or it requires the common difference. So that is it about the number pattern. In the next class now, we are going to move further on the number patterns and come up with what we call spatial patterns. Thank you.